Hello Legacy Mathematicians, Marsh again. So today we're going to look at the properties of logs, which is basically expanding and condensing logs. These properties are going to help us solve later when we're using equations with logs. So you're going to definitely want that little foldable I gave you in class to write inside, and then you're also going to want the pen or pencil and then possibly your notebook as well. Okay? So guys, have your properties things. This does include the natural logs, or ln, okay? So keep in mind that we can use ln as well for natural logs. First property we're going to talk about is what's known as a product property. Now notice guys, if I have log of a times b, what I can do is separate those a and that b, that stuff inside the log, and I can make them into their own pieces. So it would be log of a plus log of b. So keep that in mind that you can separate when you're multiplying two of the same value, or if you're multiplying inside the value of a log, you can split that into two separate logs with an addition in the middle. And we'll talk about why we can do that in a moment. Quotient property, same idea. If I'm dividing two values inside the value, I can subtract them with their own separate logs. That would be called expanding. So when I'm going from something smaller and I'm making more than one log, that's what allows me to expand it. And then the power property, if I have inside my value something raised to a power, that power can get dropped out down in front and multiplied by the log. Now, you're probably saying, huh? How can we do that? Well, if I have log base 2 of x equals the exponent. So then guys, when did we add exponents? Well, when we had the same base, right? So this would become 2 to the 7th here, right? Well, same idea. If I'm adding like things inside my log, or I'm adding two things, I can make them so they're separated into 2 or 4 plus 3. Log 4 plus log 3. When did you subtract? We subtracted when we divided. So that's the same idea as when my dividing expressions inside my log, I can subtract them. And then the same thing, we multiply exponents when we had something taken to a power on the outside. So same idea. If we have something taken to a power, what we get to do is we get to multiply by that. Because all logs are just special ways to write exponents, right? So now guys, open that first tab on the product property examples. And we're going to write inside that first tab there. So log base 3 of 6 times 11. Now, remember, our product property, what it allows us to do is take anything inside the log, and if we have stuff multiplied by each other, we can break it apart and make them into separate logs, but added together. So this first expression, I can make it log base 3 of 6 plus log base 3 of 11. So basically what I did, guys, is since we are multiplying, remember, we can add. So what I'm going to do is break it. Now notice the base did not change. Your base on these logs shall not change at all, okay? But I'll have 6 and 11, but with two logs now and adding. So I expanded. Now let's look at something without numbers. So what about 6 and y? So that is 6 times y right here. So I can make that log base 10 of 6 plus log base 10 of y. So what I did is I separated that expression and made it so I'm adding with two logs. Because ultimately, guys, that's all you're doing, is you are changing the expression to make it so you're exponents. You're kind of using the exponent rules, but in a strange little way. Log base 3 of 2 plus log base 3 of 11 plus log base 3 of 7. Now you're probably saying, well, there's no multiplication here, Marsh. Well, what I'm now going to do on this example is condense it. So normally, if we were here, we need to go backwards on this particular problem. So now I need to write this under only one log. So log base 3. Now, since I was adding each of these, all I'm going to do is multiply these numbers. So 2 times 11 times 7. Now, guys, this is why we're actually doing this, because I can make this much more simpler. Because 2 times 11 times 7 is 154. That makes it a lot simpler to write than adding all of these logs together. So that's what ultimately these properties are going to do for us, is either A, make it easier for us to solve, or B, make it easier so we can condense and expand things. Now open up the quotient property examples. We'll talk through those ones. Log base 4 of 3 minus log base 4 of 8. So guys, remember when you're subtracting, subtraction was related to division. So I'm actually going to have log base 4 of 3 divided by 8. So all I'm doing is I am dividing the two values inside of my log, because now I was subtracting 2 logs, I can change that into a division problem. What about subtraction? Notice these are ln's, guys. Remember, ln is just a fancy way to say log base e. So I can make this under 1 ln, but then I can divide the numbers. So 2 over 8. Now, 2 over 8, that does simplify. So I can make this ln of 1/4. That way it's a lot simpler. Ultimately, that would work better for you when you're solving. Now what if I have log base 6 over 11? Notice, guys, there's no base on this log. But remember, if there's not a base there, we can assume there's a little 10 sitting there. We just don't have it. Now notice, guys, I am dividing inside the value. So I can break this apart and expand it to become log base 6 minus log base 11. Okay? Let's talk about the power property now. So I have log base 4 of a times b squared. So guys, what the power property does is it tells you I can take this power right here, and just like when it was outside, we multiplied by it. So what I'm going to do is I'm going to take that little 2 and I'm going to drop it out in front. So it's going to be 2 times log base 4 of a times b. Now, ultimately, guys, I can expand this with our product property because I have a times b sitting inside there, right? So I can expand that and go a little further on this problem and be 2 times everything log base 4 of a plus log base 4 of b. Notice, guys, how I expanded it. Notice how I have a multiple parentheses, because, guys, this right here is technically all of this. So I'm actually doing 2 times all of that, so I need to show that with my parentheses. So ultimately, guys, notice because I was multiplying inside, I am now adding my double logs. What about this? Log base 6 divided by 3. Now, guys, you're probably saying, well, I don't see any exponents. I don't see a number sitting in front, so we can condense it. There's technically a 1/3 times log base 6 here, or log of 6, because this is technically 1 over 3. So ultimately, guys, if you think through this, I can multiply it back out. Now, since I have a number sitting out front here, what I can do is take it and put it back as its exponent. So it'd be log of 6 to the 1/3 power. Now let's try this one. So this, technically, I can rewrite this as 2/3 times log of 7. So now, guys, I'm going to take this guy and move him back as my exponent. So log of 7 to the 2/3 power. They are kind of strange to get used to. I definitely meant the multiple properties. When you start to look at them all together, that even gets more confusing. But let's take a look here. So I have log of 6x divided by 11 to the 5th power. Now, here's how I take care of these. I do the power property first, then I do the quotient property, and then I will do the product property. So that's how I will expand, ultimately, guys. That's how I expand in that order. So I'm going to first drop my power down. So this will become 5 log of 6x divided by 11. Now I'm going to use my quotient rule here. So remember, quotient meant we're going to subtract. So this will become log of 6x minus log of 11. Notice, guys, how I put the 5 there, just so we can make sure we keep track that 5 times all of this. Now I got multiplication here, so we need to expand that further. So I got 5 log of 6 plus, because remember, multiplication and addition work together, log of x, and then so I'm going to subtract log of 11. And just for added measure, guys, since I know 6x need to be on top, I'm going to put parentheses around that as well. So we would do that first, and then we would do the division sign. Ultimately, I'm not sure if you would really need that second set of parentheses, but just so it looks a little cleaner and so you can understand what needs to go first to get back to your original expression. Let's try the last one here. So I got 4 log base 3 of x minus 20 log base 3 of y. Now notice, guys, we're going to want to do the same kind of method as we expanded, but going to go backwards from that. So I'm going to first do my power rule. So I'm going to move him back, and I think I'm going to move this 20 back as well. So then I would have log base 3 of x to the 4th minus log base 3 of y to the 20th. Now I have subtraction, so I got to take care of my quotient rule, and subtraction was the same as division, so I'll just have 1 log x to the 4th divided by y to the 20th. And that's my final expression after it has been condensed. Now you're probably asking, why are we learning this? Why do we need to know these strange properties? Well, what it does is it helps us solve equations. So notice, guys, I would have log base 10 of 3 minus 2 log base 10 of x equals 16. I can't get to this x right now. Can't. Doesn't work. So what we would do, guys, is ultimately use these expressions to get it down to 1 log. So like I would take this 2 and drop it, because that's the power rule, right? So I got log base 10 of 3 minus log base 10 of x squared equals 16. Since I'm subtracting, I can make this under 1 log. So it'd be log base 10 of 3 divided by x squared equals 16. And now ultimately what I can do is convert to exponential form. So I can go 10 to the 16th equals 3 over x squared. And then ultimately I could solve this problem. So ultimately, guys, what these properties are going to do for us are they are going to help us solve pretty complex logarithmic equations when we need a variable inside of a log. But that's for another video. See you later, Sabers.